Welcome back to Workshop Wasteland. If this is your first time being here, thanks for stopping by and checking me out. If you've been here before, thank you so much for coming back. In today's video, we are going to be machining the Crosshead slide. Looked like a pretty straightforward piece to make. Only a little bit of dimensions on the page. Overall, thought it was going to be pretty easy. Turned out to be kind of difficult. I actually totally destroyed this piece, brought it back to life. Now we have a functional part. If you're interested in this kind of content, don't forget to subscribe. Hit the notification bell so you don't miss another one of these videos. We only have 2 components left to machine after this, and we're going to see if we have a running steam engine. Stay tuned for all of that. If you haven't checked out the other videos in this build series, make sure you click on the playlist and go back and watch all of the other videos. Thanks so much for being here. Let's get to machining. Our next piece to machine is this piece called the Crosshead, which is this casting right here. It's a brass or bronze or whatever it might be. And that piece is going to go into the engine like this and slide back and forth nice and straight, being driven off of the connecting rod from the engine. The piston is going to be, or the piston connecting rod, whatever you want to call this. This has a 1032 thread on it. This is going to be screwed into there, and it's going to make some reciprocating motion for our piston. So this isn't an overly difficult piece to machine, but there's actually a lot of machining that needs to happen on this one piece. I already cleaned up this face. Maybe I shouldn't have done that yet. That might come back and bite us in the end. But otherwise, I've cleaned stuff up with the belt sander, rounded this off pretty good up top. Just got rid of all of the mismatch from when they cast it. It was shifted like this. So if this were straight, it was shifted like this. Not that much, but you get the idea. So cleaned this all up with the belt sander. This surface right here, this one right here, is pretty good on both sides. So I'm going to start with it in the vise like this and machine the top, machine this down to the thickness, and then also hit this at the same time. So I don't know how well that's going to work. I've done some measuring, some kind of figuring out what I needed to do. Hopefully what I do is going to make sense. Hopefully it's going to work. I guess only time will tell. So let's go ahead and throw it in the mill and get started. Like I said, pretty simple piece overall, but there's a whole lot of machining that has to happen on what is arguably a pretty simple piece. So we'll see if it's going to go good, bad, or indifferent. Stay tuned. Got this piece set up here in the mill. First thing I'm going to do is clean off this surface. That's not called out in the print, but I think it'll look a lot nicer if that gets cleaned off. There's going to be mostly machined surfaces on this when we're all said and done, so why not kind of make them all machined is how I feel about it. And there's no dimension or anything, so we're just going to go for a visual cleanup here. Okay, I can live with that. Now, according to the measuring that I've done, we need to take 65 thousandths off of each side here. So we need to come in 65 and go in 65 there. And we need to leave 248 overall for this to slide back and forth on our engine. I don't really know if an edge finder is needed here. I think I'm just going to kiss it with the end mill, zero it out, come to the other side, kiss it with the end mill, zero it out, and then move either side and see how that works out. Again, I don't know if that's the absolute best way to go about this, but I do think it will work, and I think we'll be okay. So let's see how that looks. Alright, got a little kiss mark on both sides. Alright, so I'm using a 5/16 end mill. I think this is a reground end mill, so it might not be cutting true to size. I think it's going to be cutting under. And so because it's 5/16, that's of course 312 diameter, and then half of 312, just call it 125 for easy math. So I stepped out 125. Now we need to leave. This piece needs to be 248 thick when we're all said and done. So half of 248 is 124. So 125 plus 124 is 249. So I'm not going to go to 249 off the jump. I'm going to go to 260. Now we're actually going to go more than that. Let's go to 290. That's probably going to give us a bit of a pretty good cleanup here. So like I said, we're at 290 right now. Now what I can do is measure that and see what we have. Sorry, my hand is going to be completely in the way for a second. So that's 266 right now. Write this down so I can keep track of it. Well, my math went wrong somewhere. Luckily, I stepped out to 290. I don't know what I did wrong. But we need to come to 281. I'm going to go to 285 and give that a double check. That's 251. Yeah, so we need to go to 284. Okay, that looks really good. I'm going to continue buzzing this down until we just touch. Let me draw some blue right here. I want to go until we just touch this surface right here. That's going to be our 0 point, where we then need to take 25 thousandths more. So let's go ahead and buzz this around, and that'll establish our thickness. Then we're going to establish our depth. Well, I just absolutely trashed this part. I don't know that I can recover from it. I guess I could try and silver solder a piece of brass material onto here. But basically what happened, I was looking at my DRO wrong. I was at 282 on my DRO, and I ran down this face at 262, so now it's 20 thousandths undersized. I guess the smart thing to do is to carry on with what I'm doing, and maybe I can, like I said, silver solder a piece of brass onto there, machine that down, and fix it. But man, that really sucks. That feels like a hack job repair, but I don't really know what else you could do to make that repair. Crap. Well, it is what it is. Like I said, I think I'm going to continue on with what I was doing. We just encountered where I wanted to be, so we need to take 25 thousandths more. I think we just go with that. Take our 25 thousandths more, flip it over, and do the other side and see what we can come up with. Dang it, that's really annoying. That's the first side. Should be machined down to where we need it to be. And I think if I zero my Z-axis right there, when we flip this part around, we should be able to cut back down to this. We'll measure as we go, but I think that's going to be our saving grace to get us the width that we want. So let's take this out of the vise. Well, anyways, that's what we were shooting for, minus the fact that it's 20 thousandths thin. Light's making that difficult to see. But we machined that tang on there, so as you could see, that's going to ride in the engine. Deburr this and see what we can come up with. Alright, all is not lost. All hope is not gone. I got this fluxed. You can see a little tiny piece of silver solder right there. It's actually way more than I need it to be, but I want to make sure that I have enough to flow out across there. I'm going to take this little piece of brass right here. I'm going to put that right there. So you're unfortunately not going to have a wonderful view for this, simply because I don't want my camera to be too darn close. I honestly don't even know if this is going to work. My vice jaws right here are going to act as a big heat sink, so that might really hurt us in this situation. But we're going to find out. As you can see, I'm heating it from underneath and on the other side. So I don't know if you could hear what I said, but I was heating it from basically back here. And what that does is, in my opinion, I could be completely wrong, but that makes the solder draw towards the heat. So we are focusing the heat back here. That should mean it drew into that corner real nice. It actually looks pretty darn good. So I don't know how much you can see on camera, but we have a nice fillet of solder right here in that groove. I can see solder down here on the bottom. If you look in the front corner, we have solder right here that fluid out. And then over here on this side, you can see a nice fillet of solder. Oops, sorry. You can see a nice fillet of solder right there. So this just might have saved this piece. And honestly, there's no harm in trying, right? I mean, this piece of material was 34 thousandths thick. We need to machine about 20 thousandths off of this. Or actually, about 14 thousandths off of that. Plus whatever thickness the solder gave us. So I think we're going to be pretty good. I'm going to let this cool. I'll meet you back at the milling machine for us to take a look. Okay, well, did this work or not? I'm going to come out to 295. Which I don't think will even touch this part. Or if it does, it'll be very little. Take 10 more off of that. Looking for 248. 247.5, yeah, I'll take that. Let's go ahead and skim the top of this real quick. Now I want to get rid of that piece that's sticking up there. Well, what do you say we pull this out? Well, I think that's a save. I don't know how well you can even see it on camera. That looks like that made it worse. We'll have to look at it at the bench once we're all said and done, but there's a good bit of brass there, so it's not like we destroyed the integrity of what we soldered onto there. I actually think this is a pretty good save, so only one way to find out, and that will be when we assemble it. We'll see if it's good to go. If not, I can always order a new one of these pieces, so not the end of the world. Let's get this measured up, flipped over like this, and machine this other side. Maybe on this side we'll try not to make a mistake. Well, this is pretty much rinse and repeat on this side. I'm not going to do a lot of talking, mostly just going to be machining. You will see me use a depth mic and measure from this top surface down to my jaw of my vise. That's to get the overall width that we want. And then I'll clean everything up, do the same thing, center up on this, and kind of see where we're at. And then the idea is to make the top and the bottom match each other. So we'll see how it goes. We already saved the part once, so if we make a mistake, we'll save it again. Here we go. If all went according to plan, this should fit in our engine. So let's go ahead and see if it does. I'm holding the camera in my hand, so hopefully it's not too shaky. Very, very minimal play. I don't think you want it to be super tight, but slides just fine. I think overall, that's probably pretty darn good. Oh, it actually fits better that way. Yeah, so we'll probably make that the top side. And let's see if I can do this while holding the camera. Just to make sure we're not getting any binding here. If we were, we could easily adjust the thickness of these little spacers under here. Man, I'm shaky today. By God, that is wonderful. Quite happy with that. Alright, let's finish it up. Our next operation is to drill and ream a 1/4 inch hole, 250 thousandths hole into this part. This is a 500 thousandths gauge pin. I have it lined up where I want it, and I came back and double checked. I still have enough to clean this up and get our length of this part. It's interesting that the length is laid out from this hole. You would have thought it would have been laid out forward, but I guess to get this hole visually pleasing on this piece, that's why they chose to lay it out from here. But like I said, I'm real happy with the location of this. So 0 my DRO right there. Like I said, this is a 250 thousandths hole. It is getting drilled into brass, of course, or bronze, whatever this might be. So we're going to step up slowly in drill bits. I'm definitely not holding this the best in the vise, hanging all the way off the edge like this, but I think we'll get away with it. Alright, see if we can fit a 1/4 inch reamer in here. So this is a 249 reamer. The pin that they supplied for me measures about 1/2 thou under 250, so I think this is probably going to do us perfect. Here's the little pin. Nope, doesn't quite fit. Okay, well, let's hit this with an actual 1/4 inch reamer. There we go. I don't want to push that in. I probably won't be able to easily get it back out. So there's the hole for that. Now we'll take the drill chuck out. I'm going to put a 1/2 inch end mill in here and skim across the back to give us kind of a reference surface to cut to, because once we flip this around to completely cut it, we won't be able to measure in any way, or at least no easy way. I'm using a 1/2 inch reamer, so we have to think about the radius, which is of course 250, and we need to leave 1.125, so 1 inch 125 thousandths, so we need to go 1 inch 375. Which is right there. Just about had that cleaned up to the perfect point already. Actually cut about 3 thousandths off of that, so probably could have just left it alone, but try and follow the prints where we can. I'm going to get this flipped around, and we're going to machine the slot down into there, clean up the faces of these two parts, and probably clean up the face of these two as well, because we got a bit of a raised area there from drilling, which always happens, especially in brass. So let's get this flipped around and do the next operation. I got a bit of a setup block here with a slot machined in it that our part fits real nice into, so we can stand it upright like this. I'm going to use the edge finder and find the center of this part. Okay, there's our center. Now we got to machine this slot. Looks like it's 200 thou wide. It says 375 off the center of that hole. It's kind of a weird way to lay this out, but we'll figure it out. Got this part centered up. We need to make a 200 thousandths wide slot in here. This is a 3/16 end mill, which is going to be 187. So we'll have to move either side of 0, what about 6.5 thousandths to take our 13 thousandths. For right now, we're just going to go down to the depth of what we need and get to where we need to be, and then we'll worry about moving back and forth. Again, this is measured from the center of the hole, and it's down 375 from the center of the hole. So let's run this part back and forth like an argument on this end mill, and we'll get where we need to be. Alright, I am an absolute whisker away from perfectly cleaning up the bottom of that hole. And again, from the center of the hole to the bottom of this slot, we're looking at 375. If you take the radius of our 1/4 inch hole off of that, I believe that would mean we need to go 250 more from where we are, and we'll have what we need. So let's see if this works out. Now if we slide our pin in here, we must have pushed a burr into the hole. Well, we're just going to go with that. This is not a overly critical piece or an overly critical cut. This is just to make clearance for the connecting rod, so we're fine. I'm just going to go for the cut, down 250 from the bottom of the hole. That's what the math works out to be, so it should be good. Now we'll go 5 thousandths over. This is asking a lot of this end mill. And then we'll take 5 thousandths off the other side. This is a 200 thousandths slip gauge, which should not fit yet. And it doesn't, so that's good. Take 2 more off of each side. I'm being more critical than I probably need to be here. We're going to take 1 more just to be safe. And there's that feature. Not a lot to that. I'm going to machine the side of this. I'm just going to clean that up and hit the top of this. I'm going to do that off camera. That's not really explicitly called out in the plans. There's not even a finish mark on these parts. I want to clean them up because I can. So I'm going to do that off camera. Only thing left to do is clean the face off down to the level that we machined from the other position, and then we need to drill a 1032, drill and tap a 1032. I marked the position. Actually, I better drill that before I machine that mark off, but I marked the position of this from the engine. So before I go any further, we better drill that hole, or else I'm going to lose that mark and have to take it back out and do it again. Let's use the edge finder and get us at least close, and then we can adjust the position from there. So that's a gauge pin. I think that looks pretty good on the marks that I made. Hopefully it's good, because the piston needs to, I guess, essentially be square to this. The piston travel needs to be square to this. You don't have much wiggle room here. So with any luck, we're good. I guess we are about to find out. We're going to go ahead and drill this for 1032. Print told us to go a 1/2 inch deep on that hole, and that was a number 21 drill. And that's tapped to the bottom of the hole. Got that hole tapped, and I think this will be the last operation for this little part. I'm just going to dust off this backside and get it all to the level of this spot right here, which we machined from the other operation. All right, there we go. That should be our completed piece. There is our crosshead. Only thing left is some deburring. We should be ready to rock and roll and see if it fits. Let me get this cleaned up and we'll see if it fits on the engine. So this is where this puts us. I got my slide rails installed, got the crosshead installed, the piston rod, I don't know exactly what this is called, but the piston rod is threaded into there, probably 6 or 8 threads. It moves decent. It's pretty tight. I wouldn't say that it's bad. It's looser at this end, but I think it's going to wear itself in pretty well. Probably what I'm going to do is just keep pushing this back and forth and then take it apart, see if I can determine where the wear surface is, and then either machine or deburr or grind or whatever I need to do wherever the tight spot is. Like I said, it's not bad back here. It just gets tight up towards the end. However, I do think it would wear itself in. Again, brass, or bronze rather. I have play up and down on this right now, so I don't think that these slide bars are pinching it down too tight. So yeah, that's where we're at though. It fits. I think it's going to be just fine. I'm sure some tweaking and, you know, a little bit of playing around is expected on an engine like this whenever you're building it. You know, overall, I do really think that machining everything on the tight side of the tolerance is not necessarily good. I think giving yourself some clearance on all of these surfaces is probably pretty wise. In this case, everything was +0 -2 thousandths, and I tried to go right on the 0, so I can probably go back and take 2 thousandths off of everything, and this would work fantastic. I actually think that the crosshead is tight to this side, because whenever you put this rod in there, it looks like the crosshead is over this way too far visually. So I think if I could make it go that way just a smidge, all would be pretty well. But I don't want to lose the back and forth movement, because it's pretty good right now. As I've just been here playing with this in the video, it's getting a lot better. So I think it's going to start out tight. We can always connect a drill or something to the crankshaft once we get it all assembled and run it a whole bunch back and forth, you know, to wear stuff in and get it good to go. But that's where we're at.